Hello. Okay, I have problem 42 from our chapter 3 review, and it states the following. A population is represented by P equals 12,000 times e to the negative 0.122 t power. Give the values of A, K, B, and R, where P equals A times e to the kt power, which equals A times b to the t power. What do these values tell you about the population? Well, first let's define our values. We can see here that they've given us an A and they've given us a K, a B, but there's no R. Well, if you look in the book, you'll see that if P equals A, B to the T power, then it's also equal to A times 1 plus R to the T power. So there's our R right there. Our book also tells us that if B is equal to 1 plus R, that's also equal to e to the k power. And we can see here that everything's the same except for the b and e to the k. So b is equal to e to the k. That's pretty obvious. And here it's in the same place, 1 plus r. So now we can start looking for our r as well. We'll take out the easy ones. The a, the first number here in all these different formulas, is 12,000. That is our starting point. And I'll go into that later. Times e to the k, which is in this case a negative 0.122 or minus 12.2%. That is a decay rate. Whenever our power is negative in the continuous formula, that means that we have a decaying number, so I'd fully expect p to be less than our starting number, which is 12,000. Well, we have e to the negative 0.122 power. We're going to go ahead and times that in my calculator like I already did, and what I got was 0.8851. Well, this is equal to b, because remember, e to the k is equal to b. So if b equals 0.8851, so must 1 plus r is equal to 0.8851. So let's figure out what r is. I subtract 1 from both sides, and I get r is equal to negative 0.1149. Well, we're going to go ahead and change that to percent, and we're going to get a negative 11.49. So we have our b number up here with decimal form. We're going to change that to 88.51%. So now we have all our numbers. A is our starting population, and this means that when we start, we're going to have this number. P is what happens over time, which is t, usually in years. So let's take, for example, 0 years, and we can prove that this is our starting point, because at 0 years, E has a value of 1. So 1 times 12,000 is 12,000, and P is 12,000. Same with up here. If we give T a 0, we still get A. And in this formula here, if we make t 0, we still get A equals P. So 12,000 is our starting point at 0 years. K is our continuous decay rate. It's decaying because it's negative in this case. If it was positive, it would be our continuous growth rate, but it's negative. So here it is here in our original formula, our continuous decay rate. 88.5 is our growth factor. B is the growth factor here, and it can be, a decay rate is also called a growth factor, even though it's decaying. So A times the growth factor in this case would cause a smaller number. And then finally, the R in this formula here is our decay rate, which is 11.49%, which means that after 1 year, you're going to have 11.49% less than you had the year before at the beginning of the year. So what I did here was I plugged in all these different, used all 3 different formulas, the A plus 1 times 1 plus R, and the A, B, and the A to the EK, and I used all our different numbers, 12,000 times E to the negative 0.122, and I used 2 for t value in all these formulas just for consistency. What I got was 9,401. I did the same with our using the growth factor, which is 0.8851, and I got the same number. And I did the same using the decay rate, 1 plus negative 0.1149, which is this formula here. And I got the same number. So I hope that that explained it well enough for you. Thank you for watching.